yesterday I have already shared with you what a matrix looks like. Okay, what are certain terms that we use in matrices, whether is it column, row, the order of the matrix, okay, or even the element, okay, in the matrix itself. Today we're going to be looking at the addition and the subtraction, as well as the multiplication of matrices. Okay, so let's look at addition and subtraction first. Okay. Now, when it comes to addition and subtraction, it is fairly intuitive. Okay, meaning to say that if I were to be given, let's say, a matrix A with the elements P, Q, R, S, okay, and the matrix B, let's say W, X, Y, Z, and if I were to be looking at A plus B, okay, the elements, okay, they will actually add up with each other in the corresponding manner. Meaning to say, the first box over here, this first space, I'll be taking P plus W. Q I will take to add up with X. In this corner, I'll add up with Y, and in this, it will be S plus Z. Okay? However, this can only work if the order of the matrices are all the same. Okay, so we must ensure that the order must be the same, otherwise we cannot add up. So meaning to say that I cannot have maybe 1, 2, 3, 4 to add up with 5, 6, 7, 8. Okay, this is never possible. Alright, we will never be able to add up such matrices. Okay, so the order of the matrices A and B must be the same, such that, okay, the resulting matrix will actually also have the same order. Okay. So likewise, when it comes to subtracting of your matrices, okay, same concept applies. So if I were to give slightly different matrix, P, Q, R, S, T, U, and B, W, X, Y, Z, A, B. Okay, I'm giving you over here a 3 by 2 matrix. Number of rows is 3. Okay, then after that, number of columns is 2. So row by column, 3 by 2 matrix. And I will have P minus W, Q minus X, R minus Y, S minus Z, T minus A, U minus B. So same order also. So if you were to be given P, Q, R, S, okay, these matrices that represent P, Q, R, S, I want you to go and find out, okay, the value of P plus Q, P minus Q plus R, as well as R minus S, okay, provided that it is possible. If it's not possible, just write it down as not possible to evaluate. Okay, so I'll give you maybe about 5 minutes. Are we done? Are we all done? Could we just go through our answer? Okay. Question 1a, to add up P and Q. Okay, so they are possible to be added up since they are both 2 by 2 matrices. Okay, so the answer that we should be getting will be 5, 5, and then 8 and 11. 8, sorry, 13. Okay, we get 5, 5, 8, 13, right? And then in part B, okay, similar to how we do our order of operations, so P minus Q plus R, P is a 2 by 2 matrix, Q is a 2 by 2 matrix as well, so it is possible to subtract with one another, while R is also a 2 by 2 matrix, so this sum is possible. Okay, we can do it one by one, or if you use a calculator and you're very familiar, we do from left to right, okay, since there are no brackets over here. So 5 minus 0 plus negative 7. Okay, so using our calculator, you would get negative 2. Alright, then 8 minus negative 3 plus 0, I will be getting 11. 12 minus negative 4 plus 6, we get 22. 6 minus 7 plus 0, we get negative 1. Okay, do we all get that? Alright, so there's no need for you to actually show me the working that you're doing 5 minus 0 plus negative 7. Okay, so you can just key that into calculator and give me the final answer. But of course, make sure you press the calculator carefully. Alright, and then in part C, for R minus S, okay, that is not possible since this is a 2 by 2 matrix and this is a 2 by 1 matrix. Okay, so we cannot add matrices or subtract matrices that are of different orders. So not possible to evaluate since R is a 2 by 2 matrix while S is a 2 by 1 matrix. Okay, so I hope that you're able to get these answers. Next, we look at question 2. Question 2 has given you a matrix that is representative of the first test for maths and science, okay, scored by different people. So in this matrix itself, they have actually labeled for you, okay, what it means. So they did not actually give you a table, so they directly give you a matrix, right, which may not always happen. Okay, so Raj actually got 49 for math, 47 for science, Ethan got 28 for math, 45 for science, and Farhan 39 and 21 respectively. Then in the second test, okay, Raj, Ethan, and Farhan got these scores, right, for the math and science. Okay, and in part I, we want to express the marks for the second test using a matrix with the same order as P. Alright, so the question specifically said that it is in the same order. So we do a 2 by 3 matrix. So following the same arrangement, Raj comes first, 46, and then 42, 40, 38, 31, and 35. So this will be the matrix Q. And then in part 2, to find the matrix P plus Q, so could you do a quick calculation? Find out what is the matrix P plus Q going to be. so what do we get? Azia, can you tell me what is your answer for matrix P plus Q? Left to right on the first row. 49 plus 46. Can you tell me the answer? Next one.
68.
Okay, next.
70.
Alright. Second row.
89.
Uh-huh.
83.
Yep. 56. Okay, so this should be the matrix for P plus Q. Alright. And in part 3, you are asked to actually explain what the elements in the matrix in part 2 actually represent. So what do you think they represent? Katie, what do you think they represent? These elements, how will you phrase it out in words? Give it a try. Why you look at me like that? You add up the scores, so what do the elements represent? Sorry? The sum of both tests, okay? So the numbers represent the sum of both tests. Do you think this answer is sufficient, the sum of both tests, to describe the elements found inside this matrix? The numbers represent the sum of both tests. How many of you think that you will also be writing this? Who thinks that you're not going to be writing this? Then what would you write? Okay, it is the sum of both tests for both for Raj, Ethan, and who else? Farhan. Okay, for Raj, Ethan, and Farhan. Okay, how many of you will actually continue in writing this sentence? Alright, okay, so I think that there's definitely a need for more elaboration when it comes to what Kaylee has suggested. Okay, the numbers represent the sum of both tests, which isn't exactly all the elements, because the sum of both tests, okay, actually mean that we're taking 49, 28, 39, right? Add them up together with 95, 60, 70, add them up together. So all the numbers in the first row, okay, first row of both matrix, okay, adding up together, right? So the sum of both tests is a very vague kind of description to talk about the elements. Okay. Then after that, going on to say that it is for Raj, Ethan, and Farhan. So because we're dividing into 3 columns over here, where it's Raj, Ethan, and Farhan, right? That does seem to actually break down, okay, the number itself, okay, to actually talk about the rows and columns of the matrix. But something else is also missing, okay, which is talking about the subjects of the test as well. Okay, so because this one is supposed to represent maths, the other one is for science. So to more accurately capture the whole idea of this matrix, maybe what you could say is that the sum of the numbers represent the sum of both tests. Hang on, listen. Okay. Represent the. Okay. Let me rephrase this. The numbers represent the total marks achieved for each subject by each of the students. Represent the total marks achieved for each subject by each of the students. Okay, so we talk about the subject, Alright, the number of students, okay, and then also that it is a total mark. Okay, so that's all for exercise for chapter 4.2. Okay, so exercise 4B, homework question 4, 5, and 6. Alright, this one can be due next week, I suppose, on Wednesday. Alright, due on the 10th. Okay, we're going to next look at matrix multiplication, which is not intuitive at all as for how we see our addition and subtraction. Okay, so when it comes to matrix multiplication, an intuitive way will be that we take the element, okay, and multiply with each other. But that is not something that we that is defined, okay, for our matrix multiplication. Alright, so there are two ways for us to actually look at matrix multiplication. One is if we are going to multiply a matrix itself by a number. So let's say if I have a matrix 2A. Okay, so let's say my A, I let it to be PQRS. Okay, so if I put a number 2 in front of the matrix A, how I write this out will be writing in this manner. Okay, and to do the matrix multiplication in this case, we are going to multiply that number with each of the elements found in the matrix. So it becomes 2P, 2Q, 2R, 2S. Okay, so as long as we are taking a constant number, this is a constant number, not a matrix, because there are no brackets. So it is not a 1-by-1 matrix, it is just a number itself. Then this is how we go about doing our multiplication. Okay? Okay, let's work on some examples first. We want to evaluate what is 3A plus 2B. So it will mean to take 3 times of the matrix A. And 2 times the matrix B. Okay, then we add the elements, okay, correspondingly. Okay, so 3 times 2 plus 2 times 4 for the first element. Okay, we are going to be getting a 3/2 matrix at the end. Then 3 times -3 plus 2 times 0. I'm just showing out the working so they understand my thought process. You could use your calculator to press it very quickly. Just that if you were to write the working, make sure that you leave sufficient space between the elements so that you don't get yourself confused. Okay. then we get 14, negative 9, negative 5, 11, 0, 46. Right? Could you do part 2 very quickly? 4b minus 3a. Determine the value. 3 minutes, okay? Okay, are we able to get the answer for part 2? What is your answer, Amanda? 10, 31, negative 54 and negative 55 and 20. Okay, are we all able to get this? Can get, right? Okay, just use your calculator to press. In part A for question 2, we want to determine the value of x and y. Alright, so we learned the concept of equal matrices yesterday. So in this case, given that you have these two matrices adding and multiplying, okay, and they will get you this 3, 6, negative 2. Okay, so what we can do is that we can break it up. Can think of negative 2x plus 4 is equals to 3 times 6. Since we know that the corresponding elements will add up or multiply with one another. Okay, then you can solve to find out what is the value of x. That is negative 7. Do the same way for finding y. we get another equation, negative 2y plus 2 is equals to 3 negative 2. So y is equals to 4. Alright. So could I just give you 2 minutes to do part B? Determine the value of x and y. Joseph, can you wake up? Can you do part B? Have you done it already? Then you may want to consider doing homework first rather than to sleep. So, Dylan wants to answer for x. Sorry. Eleven over 2, which is also 5.5. What about y? Nicole, what do you get? 22. Okay, so y is 22. Do we all get it? Right? Okay. Let's look at practice now for some problem sum. Okay, when it comes to problem sum, it is important to read the words. The question actually says that a chartered bus carries passengers daily from Monday to Friday. The number of adults and children it carries each morning and afternoon, okay, is given in the matrix D. So this matrix itself is only representative of daily situation. Okay, so it's either Monday, Tuesday, Wednesday, Thursday, or Friday. In part I, we want to find the total number of adults and children carried by the bus, okay, from Monday all the way to Friday. So we want 5 days in total, okay, in mornings and afternoon. We want to express your answer in matrix form. Okay, so to understand this matrix, number of adults in the morning is actually 15, children in the morning is 25, and so on. Alright, so 5 days, okay, that means that for every element I need to times 5. Okay, it will be a very silly thing to do if you extract out the number and then you times 5 individually and then put it back into the matrix. Okay, we understand the idea of multiplication, okay, already. So what we can do instead is that we are actually looking at 5D as a matrix. So that means 5 times the matrix D. Then we just, essentially we still have to multiply it, okay, individually. But we can key that into a calculator. And this will be what we get. at Saturday morning, in the bus will actually carry 14 adults and 10 children. Then in the afternoon, it is 18 adults and 7 children. You want to represent it using the matrix E. They did not quite give the order, okay, of the matrix that you're supposed to represent in. Alright. However, do take note of the requirements in part 3. Because in part 3, you are going to take 5D plus E. Okay, and we see that 5D is a 2 by 2 matrix. So in order to add up with another matrix E, E has got to be a 2 by 2 matrix as well. Right? So therefore, we can make use of part 3 to deduce what is the order, okay, of the matrix E required. Right? Otherwise, okay, a logical presentation will be to follow how the daily matrix D is actually written. Right? So since you're looking at Saturday morning, okay, so morning itself will be in the first row. Adults come first, so 14 and 10, then 18 and 7. Okay, so this should be how your matrix E looks like. Then the matrix 5D plus E. We will be looking at this sum. Okay, and in part 3, they actually ask you to explain what the matrix 5D plus E represents. Right, so how would you go about describing this matrix? What do you think? Noi, how would you attempt to describe this matrix? Okay, hang on. It represents, sorry, I can't hear you from here, so let me maybe just write it here. Say again. The total number of adults and children carried by the bus Okay. Anything else? No? Anybody else have things to add to this explanation of the matrix? Yep. Anybody? Sorry? Okay, in the mornings and afternoon. Okay, so I think that this will be a sufficient explanation for the matrix because you covered the point on adults and children, and it is from Monday to Saturday, and then also it is from morning to the afternoon. So in this question, right, one way to help yourself in describing the matrix is to look at how they describe it, okay, for D. Okay, so at the start of the question, there is a description, so you can rely on that statement itself to form your sentence, okay, rather than to stress yourself out in creating it from scratch. Okay, the next is the most important one, which is on two matrices multiplying with each other. Okay, So we have seen taking a number multiplying with a matrix. Okay, the more complicated one is to multiply two matrices together. Okay, when multiplying two matrices together, you need to check the order of the matrices. Okay, because it is not intuitive whereby we take the corresponding element and multiply with each other. Okay, so let's say the matrix A itself has the order m times n, where if you could recall that m is the number of rows and n is the column. Okay, then if B has a certain order, okay, for matrix multiplication to work, the order of B must have the number of rows to be the same as number of columns. Okay, for A. So this number here must both be the same. Right? Then multiply with, so not say multiply, okay, but the number of columns, okay, can be any other number. So let's say maybe P. Okay, so one very crucial thing about matrix multiplication is that the number of columns of A must be equal to number of rows of B. Okay, so that's the first thing that you must check. Alright, I explain the mechanics of it later on. Okay, then the order of C, which is the resulting matrix, will be having the order m by P. P is a number. Yeah. Okay, so m, n, and P they're all numbers. Okay, so example. Okay, so let's say if I were to have a 3 by 2 matrix A. So 3 by 2. Okay, so 1, 2, 3, 4, 5, 6. So this is a 3 by 2 matrix. Okay, the order of the matrix B that we are going to take to multiply A must have 2 rows. Okay, so it must be, let's say maybe 5, 6, 7, 8. So this is a 2 by 2 matrix. We see that number of columns here, number of rows is the same. So I can do a A times B and get a certain matrix. Let's say call it C. Okay, so I'm not going into the mechanics yet. Right, so C itself, this will be a 3 by 2 matrix. Okay. Another example. Okay, instead of taking A times B, let's say if I have a D. Okay, I still need it to be a 2 by, need to have 2 rows. Okay, so 5 and 6, right? But I did not care about number of columns, so I can have 7, 8, 9, 10, 11, 12. Okay, and this is a 2 by 4 matrix. So if I were to take A multiply with D, let's say I get a matrix F. My matrix F will have to be a 3 by 4 matrix. Okay, understand now? Right, so this is the very first thing that you must check. Okay, my next question is, can I take B over here to multiply with A? Meaning to say I get B times A. Is that a possible combination? Can I do B times A? Okay, so let's check. B is a 2 by 2 matrix. A is a 3 by 2 matrix. We see that number of columns and number of rows here are not equal. So it is not possible to get any matrix out of it. Okay, so not possible. right? So what this tells us is that unlike in our numbers, we know that 2 times 3 and 3 times 2 both give us 6. I don't need to care about the order of the numbers. But when it comes to matrices, the order of the matrix itself matters. I may be able to do A times B, but I may not be able to do B times A. Okay? There is only in certain combinations that I can do A times B, B times A. Okay? One such combination, if it's both matrices are actually square matrices, or they have the same order. So then you will get you will be able to do A times B and B times A. Okay? But we're not going to be looking into that. Okay? It's just for your information. But we must know, okay, the order of the matrices in order to multiply. Okay, so let me now go through with you the mechanics of the multiplication. So, example, if I have 2, -7, -3, 0, 5, 8, and I multiply with this. Okay, so this is a 2 by 3 matrix. This is a 3 by 2 matrix. I will know that my end product must be a 2 by 2 matrix. Okay, so the first step in doing your matrix multiplication is to check order of matrices. So now, how to multiply and add? Okay, put your pens down, you watch how I do it. Okay, so we are going to be looking at the first row of the matrix on the left and the first column of the matrix on the right. We have 2 by 2, so that means I got 4 spaces here. Okay, first space belongs to first row, first column. Right, first row, first column. So first row, first column. I will take 2 times 4 plus -3 times -5 plus 5 times 21. Okay, so that's the mechanics. We take 2 times 4, so let me just write it out. Okay, so 2 times 4, let me just drop the times, plus -3 times -5 plus 5 times 21. Okay, so that will be in my first space. Alright? Then in my second space over here, it is the first row, second column. I go for first row, second column. So I take 2 times -9, -3 times 10, plus 5 times 6. Okay, so that will be 2, -9, plus -3, 10, and 5 and 6. Okay, so it's like flipping your pata, I don't know lah. Okay, I visualize it in my mind. This one flip, match, and then multiply and add. Okay, then next one, next one actually belongs to second row, first column. So second row, first column. So we take -7 times 4 plus 0 times -5 plus 8 times 21. Okay, then last one will be second row, second column, second row, second column. So -7 times -9, 0 and 10, 8 and 6. Okay, you follow me with the mechanics? Right, so it is not intuitive. Okay, it requires some getting used to. Alright? You may want to copy this down first. Okay, but of course I don't require you to write down the steps. Okay, this is for our starters only, so that's why I'm writing down the steps. Okay, so that you can go back and follow up on it. But once you get the hang of it, you can press into your calculator and generate these numbers. Okay? Okay, so take the row of the left one, column of the right one, multiply and add. You may be able to write it in your words better. Okay, so whatever that you can understand. Okay, let's figure out the order of these two matrices when you multiply. Okay, what's the n matrix going to be like? Let's figure out the order together. Then I'll let you go and explore. Okay, what's the order of this matrix here? Joseph, order? Sorry? 2 by 3. 3 by 2. Okay, this is a 3 by 2 matrix. And the order of this one, which one? 2 by 3. Can we multiply together? Okay, we cannot. So this number and this number are the same. Okay? Our end product. What is the order of the n matrix? Alia? Sorry? 3 by 3. Okay? So 3 by 3. Right? So could you practice the mechanism that I've just taught you? Okay? Try out for this matrix, right, and get the answer for this question.